So now I want to get back to an exponential equation that we looked at when we first started looking at logarithms. This 2 to the x equals 3. We said that we could find, obviously we could solve the equation 2 to the x equals 2 or 2 to the x equals 8 as long as it was, you know, the number on the right was a nice power of 2. 3, we don't think of it as a power of 2. There's no integer an integer solution for x in this case. But now we can use logs to solve this. And the way we do that is if we take the natural log of both sides, and we only choose the natural log because that's, you know, we have that on our calculator. So this is the, so if we take the natural log of both sides, we get log of 2 to the x equals log 3. Then by our properties of logs, this x can come out front. Now what we have here is we have x times a number equals another number. This is something we should know how to do because this is just a basic algebra 1 equation. If I asked you to solve the equation, you know, x times 5 equals 7, you would just divide by 5 and solve it, right? Well, here we instead of a nice round number, we have a log 2. Okay, it's still a number. We do the same thing. We divide both sides by log 2, and we get this. Okay, so we have natural log of 3 divided by natural log of 2. And if we wanted to get an approximation to this, we would just take our calculator out, okay, and take, so we would have log of 3 divided by log 2, and we get 1.585. We'll round it to 3 digits. Okay. Approximation. It's important that the ln's do not cancel out, right? This is not 3 halves. This is log of 3 divided by log 2. Now we can see that we can find the log, any log, doing this same way. For example, if we wanted to find the solution to a to the x equals m, we would just do the same thing. Take the natural log of both sides, bring the x out front, divide both sides by log a, and we get x as natural log of m divided by natural log of a. Okay, that's exactly how we get this formula. So the log of m with respect to any base can be the natural log of m divided by the natural log of a. Okay, so, and notice that this is also equal to the common log of m divided by the common log of a. Because if you go back here, we could do the same thing instead of using ln, we could do the same thing with log. Okay, all the properties still hold, right? All the steps would still be valid. And that's interesting because obviously the common log of m is different from the the natural log of n. And the natural log of a is different from the common log of a, but these fractions are going to be the same. Okay, so now we can just get by. That's why we can write all the logs just in terms of the natural log or the common log, and most of the time we'll use the natural log. And also we should see every positive number can be written in terms of a power of e using natural logs. So 2 is e to the natural log of 2, and as a result 2 to the x is equal to e to the natural log of 2 times x. And that's why the graphs of 2 to the x and e to the x are almost identical. Okay, because when we replace x with some positive number times x, you're just stretching it a little bit, and the intercepts will stay the same. So that's why the graph is going to be basically the same for all, whenever the base is bigger than 1. Okay, then we also have this change of base formula. We can do this with respect to any base. We don't use too much of it here. Or the main formulas we'll be using are here, but we can always write a log in one base in terms of the logs of another base. And where we have the log of m base a is the log of m base b divided by the log of a base b. And basically, you would just do the same steps you did up here, except instead of using natural log, you use log base b. Okay, so this is actually a special case of this change of base formula. All right, so now we can just, if we wanted to approximate these, we would just use this formula. So the log, this is going to be the natural log of 18 divided by the natural log of 5. This is the natural log of square root 2 divided by the natural log of pi. And this is the natural log of e divided by the natural log of square root 3. Okay. And then we'll pause the video and find the decimal approximations. And here they are. Just took me a couple minutes to plug these into the calculator. Okay. I'm going to be much more interested in you writing things in this form than these. I mean, they'll probably ask you for some decimal approximations on your homework, and I might do that on one problem on a quiz. But the important thing is just using the formula above in the right situation.